Okay guys, so we're now on Unit 1, Lesson 4 notes, and we're going to be talking about function operations. So the very first thing that we're going to be discussing would be function notation. So let me get my pen. So function notation equals f of x. You read this as one of two ways. Function of x, or f of x, or f of x. So you've got how to write it both ways. So there's two ways you can write it. F of x is the same as y, which is your output value, which is the dependent quality. The x input value is the independent quality that you simply plug into the function. So if you're looking at our little table below here, you've got our x's, which is our inputs, we've got our function rule, and then our output, our f of x. So if we're going to plug our function in, we're going to show you how it works. So our first one we have here is f of negative 3. So we're going to plug that negative 3 into our function rule. So it's f of negative 3 equals, so we're going to plug that negative 3 into every x. So 2 negative 3 plus 5. So that's going to be how you do this. So then your output is what you get for the answer, which in this case would be 11. So now we're going to be looking at the next one. So we've got f of 0. So f of 0, plug in the 0 at all the locations. You've got negative 2, 0 plus 5 equals 5. So then if we look at our last one, we've got f of 1/2. So it's f of half equals negative 2 half plus 5. So then you're going to get f of half equals 4. So now we're going to look at our examples. So for example 1, evaluate each function. If f of x equals 2x plus 3, find the following. So we're trying to solve for each one. So if we have f of 4, we're going to plug that in. So f of 4 equals 2x plus 3. So now we're going to be plugging in 4 for each x in our equation. So f of 4 equals 2 times 4 plus 3. Doing our simple addition subtraction, f of 4 equals 8 plus 3, which is going to give us 11. Now we're going to go over to example B. So we have f of negative 1 equals 2x plus 3. So we're going to plug in negative 1. We're going to have f of negative 1 equals 2 negative. So we've got f of negative 1 equals 2 negative 1 plus 3. So that's going to mean f negative 1. So we've got 2 times negative 1. That's going to be negative 2 plus 3, which is going to give us 1 as our final answer for this one. F of negative 1 equals. Okay, now we're going to look at example B. If g of x equals x squared plus 2 and h of x equals 4x plus 10, find the following. So we've got our h of 3, and we're going to use that equation, 4x plus 10. Then we're going to plug in the 3 with all the x's. So h of 3 equals 4 times 3 plus 10. That's going to give us h of 3 equals 12 plus 10, which is going to give us 22. Okay, so now we're going to go to B. We've got g of negative 3. So we're going to use the g of x equation, which is x squared plus 2. So we're going to plug in that negative 3. So you've got negative 3 squared plus 2, which is going to give us g negative 3 equals 11. Because you get that negative 3 times negative 3, which is going to be 9 plus 2. Then we're going to go to C, which is g of a. So a is a little bit different. It is still a number, but we don't know what number it is. So we're still going to use that same equation. We're just going to plug in a like it was any other number. So it's g of a equals x squared plus 2. We're going to just plug in a for x, just like we did. G of a equals a squared plus 2. And since we can't do anything more, since we don't know what a is, that's our answer. So now we do the same thing for h of a plus 1. So it's the same kind of setup. So we're going to do 4x plus 10, and we're going to plug in the a plus 1 into our x. So h a plus 1 equals 4 times a plus 1 plus 10. Now we can simplify this a little bit more by distributing our 4. So that's going to leave us getting h of a plus 1 equals 4a plus 4 plus 10, which ends us having h of a plus 1 equals 4a plus 14 for our final answer. All right, we're going to do the same thing but with new equations. So we've got our g of 2/3. So we're going to do g of 2/3, and we're going to plug in the g of x equation. So we've got g of 2/3 equals 2x squared minus 7. So we're going to plug that 2/3 into x. So g of 2/3 equals 2 times 2/3 squared minus 7. So remember, doing fractions, it's going to be a little bit different. So we are going to do the 2/3 squared, which means you're going to be multiplying 2/3 times 2/3, which will give you 4/9 because you multiply across. So you're going to have 2 times 4/9 minus 7. So 2 times 4/9, again, it's still a fraction, but you have to do it a little bit differently. And you're going to end up with 8/9 minus 7. So there's two ways you can write this. It can either be, so it's going to be g of 2/3 equals -6 1/9 or -55/9. Both are acceptable answers, but remember you're going to have to do that and do your fractions. So our next one is f of 1/5. So we're going to have f of 1/5 equals x squared plus 5x minus 4. So when you do this, we're going to plug in our 1/5 into everything. So f of 1/5 equals 1/5 squared plus 5 times 1/5 minus 4. So again, we're going to be multiplying fractions. So 1/5 times 1/5 would be 1/25. Okay, so you're going to have 1/25 plus 1, because 5 times 1/5 is just going to be 1, minus 4. So your answer, again, can be written in a couple ways. So you're going to have 26 over 5 minus 4 to start with once you combine those. So you're going to have f of 1/5 equals either -74/25 or -2 24/25.